Good morning. Week 5, Wednesday. I'll talk to you about agenda for today. First of all, more important, term test 1, October 4th, and it's going to be on a Friday from 6:30 to 9 o'clock p.m. You're going to get 3 questions. Questions are going to be from the lecture. Okay, so any example that I do in class, and also from your homework. The content or the test will be based on homework 01, homework 02, and homework 03. Okay, just a quick reminder. Now, I post this out on September 30th. This is the formula sheet that you'll be getting. Anything that's not here, you have to remember. Room allocation. If your last name is El Rijal to Jeong, your room will be in MDCL 1110. You all know where MDCL is, I believe that, right? And the invigilator will be Adil and Jari Rai. Then from Dream to Srimis, MDCL 1309. Invigilator will be Ismail and Mastri. And from Smith to Zunti, T13. You all know where T13 is? Okay, temporary building 13, room 127, Mewikon. Okay, so these are your allocated rooms. If you're not sure where your room is, contact me. Okay, anyone not sure? You know where you should be going, am I right? Good. What else I have to remind you? That's it for your term test. Okay. Okay. Something slipped my mind. Will come back to me. Tomorrow there'll be no lecture, no tutorial. Okay. Go and study. Are we clear? Okay. Not like, oh, there's no class on Eugene. From Eugene tomorrow, tonight we go drinking. Don't do that. Okay. Study. Okay, I'll be in my office. You can come and see me anytime, ETV 216. Okay, come and see me if you have question, 9:30 to 11:20 p.m. a.m. p.m. Really? Okay, come and see me. Okay, if you have burning questions that you're not sure, come and see me. Okay. The next thing is, on Thursday, a student asked why dr over dt is not equal to 0, where r is a constant. Okay, I'd like to sort that out with that question. I think it's really a good question. Questions like this I believe, make the lecture better for yourself and also for future students. And then we're going to start on a new topic, which is known as absolute motion analysis. Okay, I'll highlight it here, not tested on term test 1. I don't want you to panic because it's not fair. Whatever I teach today, you have a test on Friday. That's not fair. Okay. So by looking at the diagram, with reference to the diagram, we wrote that acceleration is equal to dv over dt. Okay. And then we have a function, we differentiate it. We have a function d omega dt cross r plus by omega cross dr over dt. The question asks why dr over dt is not why it should be equal to 0 as r is a what? Constant. Okay. Now r is a constant when it is a what? When it's a scalar. Okay, if we look at R can be represented, okay, so what is R? R is a distance between what? Between point O to point P. Agree? It's a constant. Okay. However, point P can be expressed as a Cartesian coordinate during analysis. Okay. So what do I mean by that? Okay, what do I mean by that? If I were to draw a transformation, I call this my X, this is my Y, and this is my Z. Okay. And over here, we have our point. I'm going to follow our label, our point O. And I'm going to have point P over here. Okay. And over here, is our X, Y, and Z. And in our Cartesian form is I, J, and K. Okay. So not assuming, if I were to define the radius or R is equal to 3 meters, right? And we know for a fact that the radius over here, right? The distance from here to any point here, the radius over here, R, will always be what? 3 meters. Okay. Now, when P moves to P prime, we have a certain angle over here known as what? Theta. At this point over here, there is a certain what? Coordinate in Cartesian form. Okay. And this coordinate will look like this. Will look like R cos theta I and R sine theta j. Now, knowing that R is still constant, can you tell me more about I and J? When theta changes, what happened to I and J? Will it change? Yes or no? It will change. Okay. So because of this change, dr over dt is not equal to what? 0. I repeat again, because of this I theta that's changing, will change the I and J magnitude. That's why dr over dt is not equal to what? 0. Happy with the explanation? Some of you are. You are late. You happy with the explanation? I'll go through it again, okay? At point P to P prime, you have an angle theta. R is a constant, and we know for the fact the question asks why dr over dt is not equal to 0. Okay, and the reason why, when I and J, with I and J, theta is always changing with what? Time, when we have what? When we have a omega. Okay, so when that's the case, point P prime in terms of I and j is changing with what? With time. That is why dr over dt is not equal to what? 0. Okay. Very theoretical. Happy with it? Yes or no? Some of you like, it's okay. You're not happy with it. So what I've done over here is I want to make you visualize. Okay. So what I've done over here, I've stated that the radius, I'll show you what's going on over here. Don't worry. This is just Excel. Okay. I specify the radius is equal to what? If I can share, okay, if we can share both screen. Okay. I specify over here that radius is what? Equal to 3. Okay. So what I did further, I have theta. So theta equal to 0 relative to the diagram. This is all. Sorry, I see. Can I do this? Okay, if I can do this, it'll be fantastic. Okay. So over here, you see that theta is equal to 0, and then it go to 360. Where 0 is, this is where 0 is. Okay, so this is where at this point is where theta is equal to 0. Okay, and then positive means anti-clockwise. And then from here, you can see that we compute our I and j what? Coordinates. And then after that, with the I and j value, if you can see the formula, okay, I did I squared plus by what? J squared. This resulted that the radius is equal to constant in a what? In a scalar form. Okay, as you can see over here. I put a angular velocity of 2 radians per second. Okay, and then I compute velocity in I and velocity in j and so on and so on. So let's look at the graph. The graph you see down here is scalar radius. Regardless of the angle of rotation, the radius is always what? 3 meters. That's correct. If you look at the amplitude of the velocity from 0 to 360, the velocity is also what? Constant. Y velocity in scalar form is omega r. Now I change to vector form. If you look at the I position of point P, means I position is this position. So this over here has an I coordinate and also has a what? J coordinate. What you realize down here, depending on the angle theta, the value I changes with what? With time. If I were to look at the next one, this is J. Based on the x-axis is again what? It's again the angle, the y-axis. The y-axis is the J position. It's changing with time. Now, we know that location P, right, changes with time relative to what? I and J coordinate. Now, if you look over here on my graph over here, you realize that Eugene, you were saying velocity is constant. If velocity is constant, then where did we get the tangential acceleration and the what? Normal acceleration. And it's a fact, when you go about a circle, what can you feel? You can feel the linear acceleration and you can also feel the what? You can feel the tangential acceleration. You can also feel the normal acceleration. Okay, you don't believe me? Just drive 60 kilo or 90 kilometers per hour, turn suddenly and see what happened. Okay, so when that's the case, my graph disappeared. The next graph over here, okay, that you see is the position or angle of rotation relative in velocity in the what? I direction is changing with what? With angle, with theta, and J is also changing with what? Velocity is changing with what? With the angular position. Okay. I realize that this might not be good enough because you were